Okay, I know many of you have long been awaiting getting to the part where I finally talk to you about using modules and packages within Python, and we are here. Like I mentioned in class, I like you to kind of get some of the logic and basics down of manipulating objects within Python before you start relying upon these modules and packages. Because now you're going to have a broader base of skills to be able to more reasonably uh, choose what you need to install and reference in Python. Okay, so a little bit about background. A module is just a single file. Okay, it's nothing more than that. You simply import that file and use it. So you may have seen statements such as import followed by some module name. Okay, there's not a module, by the way, called some module. I've had somebody ask me that. I can't find that module, some module. It's not a module. It's just I'm making generic reference to some module. Um, Whenever you see that, you know that you're importing a module of whatever name follows the import statement. In contrast, a package is a collection of modules that are stored in directories that give some sort of package hierarchy. So we might import a module or a function from a package. So we could say import a package using a statement like this from some package name right there, import some function name. So if you just need to use a function that you know is stored in a particular package, you can use this kind of syntax to then have access to that function. Another thing you see quite frequently is you'll see some package name dot some module name dot some function name. That way you can just directly reference it. Sometimes that gets really, really long. And so we'll import, NumPy as NU or something, and then we can make reference to it so it's not so long. But you do see this from time to time, especially if you've imported modules in a way that you can make quick and easy reference to them. It makes sense to maybe use this kind of syntax. Okay, so big lesson here. In essence, you can install a package and then use those functions. Okay, you have to install it using like a pip command, maybe conda. Uh, Even a user-defined function that you yourself have written can be saved as a PY file and used as a module. So I like to do that. I think that's a really great way um, to not make your code too long and difficult to read. Is I like to break it up, just like I coached you to do in R. Break everything up into functions, call your functions. You can actually really read and make sense of your code. There's a lot behind the scenes going on, but it's easier to follow the logic than when you kind of get lost in the forest because you've got all the details out in front of you at all times. If you know there's a problem with a function, well, go to that Python file and fix the function. Don't try to put everything within one set of code. So again, the same idea. So this is going to be a concept tests that we bring into class like we sometimes do. These are two modules, okay? Or this is actually, I can't remember. I left it in one module. It will write Fibonacci numbers or series up to some value n. So notice the user has to provide the value for n. And then this simply is going to print out an object. So let's spend a little time, we'll spend a little time making sure we understand the difference. Notice one of these uses a print and then end statement within print, while the other one appends and then returns result. So you're always appending your result here, and then you return result at the end. Here we just give a universal print statement, so everything within here is printed. A and B are going to be updated also. So if I say import Fibo, Fibo again contains all of this code. It's a PY file. okay? And then I say print fibbo.fib 1000 and print fibbo.fib2. Remember, this one's fib, this one's fib2. Does this code use a module or a package? Think for a moment. Your options are module only, package only. It uses both, or it uses neither. Okay, so remember, and you can, I hopefully will remember to attach the fibbo.py file, but it is a Python file, and we're importing it as a module. So this is a module, A. I could modify that slightly. I could say from fibbo import fib. So is it treating my fibbo.py file as a module here or as a package? Oh, notice below, I don't have to do fibbo.fib because I've imported the function directly, making reference to fibbo here. Well, it's in my opinion treating it more like a package, right? So again, don't just look at this, test out the code, make sure you can get that Fibonacci sequence. Don't worry about making it 1000, make it 10. I don't care what number you have in there. You can also use things like this. So from Fibbo, import asterisk. This is going to import, well, now I'm telling you the answer. What do you predict this will import? I actually can run both fib and fib2, which kind of gives you the answer here. Predict the result. Will it run both fib1 and or fib and fib2? Or will it run neither? Is this complete nonsense or none of the above? I couldn't think what else to say, hence none of the above. Okay, try it out. When you use this asterisk, what's happening? It's going to import every single function within Fibbo, which in this case is fib and fib2. So make your state. Now I've pretty much given it away, but that's okay. Okay, I'm going to stop here and then get a little bit more into specific Python modules in the next video. So I'm breaking from my routine here because I'm realizing I'm looking at the time. It's nearly 8 minutes and I don't want to go too long on this video.